double prime. Okay, go to blue. F double prime, Demis.
You take the derivative of that, which will end up being 20 over 6
9.
over 9, x to the negative 1/3,
Good, yeah.
minus 20 over 9,
Good.
x to the negative 2/3.
Negative 2/3, good. Okay, so there's our F double prime. I believe that's part E. And then we need to find the coordinates of the point of inflection. So this is E. Okay, now what?
And for the next question, to find where f of x has points of inflection, you have to set the second derivative of it equal to 0.
Equal to 0, so let's set this equal to 0.
You did what you always did before.
Okay, before we move on though, can I
Okay.
plug in 0?
Yes, you can.
No, I can't.
Oh, wait.
It's x to the minus 1/3 now, which means it goes below.
Oh, and if it's 0, it doesn't exist.
So it looks like this. And if I plug in 0, it doesn't exist anymore. So no, I can't. It's clever. All right. So, yeah, I think you're right. Let's move things to the other side now. So let's move this one over. So we get 20 over 9 equals, 20 over 9 x to the minus 1/3 equals 20 over 9 x to the minus 2/3. All right.
And you can raise the x's to the minus 3, possibly? Or the
minus 3.
Oh, no, that wouldn't help.
Well, let's get rid of these
Yeah.
20s and 9s
Yeah.
first.
You can just divide them.
Yeah, just divide them. So multiply both sides by 9. Those go away. Divide each side by 20. Those go away. And we're left with that. Okay, so this is 1 over x to the 1/3. I hate negative exponents. Plus, or equals 1 over x to the 2/3. I can cross multiply.
And you'll end up with x to the 1/3.
2/3, whoops. X to the 2/3 equals x to the 1/3. Hey, I can just get rid of those negatives, can't I? I could have just raised it to the negative 1 as well on both sides. Same thing. Okay, and now?
So now you could, I think, raise it to the power of 3, yeah?
Good. I think we've done that a few times now. And we get
X squared equals x.
x squared equals x.
And that can equal a range of things, couldn't it?
Well, x squared minus x equals 0.
Oh, so x minus 1 equals 0, x equals 0 or 1.
But can x equal 0?
No, it can't.
No, we
Because
already
of
knew
the-
that. So that one's gone. So it looks like we have a candidate for point of inflection at x equals 1. Okay, we need to determine if it is by doing a little concavity test. So it has to go from concave up to concave down in order for it to be a point of inflection, or concave down to concave up. So let's just plug, what can we do? Let's plug, we can't plug in 0. Plug in, I think we can just plug it in here. Let's plug in negative 1. So negative 1, that's negative 2 times negative 1.
Be positive.
Positive, no, that's not right. We can't plug it in there.
It needs to be in the original equation, probably.
Yeah, let's plug it in here. Negative 1.
Negative 1 to the power of 3, or not to the power of negative 1, which is 1. So that's positive.
Well, let's, if we plug in negative 1 here, let's see. 20 over 9 negative 1 to the 1/3 minus 20 over 9 to the negative 1 to the 2/3. That's our f double prime, right? Okay, negative 1 to the 1/3 is negative 1. So that's negative 20 over 9. minus, and this is 1. Negative 1 to the 1/3 is negative 1. Squared is 1. So that's
Minus it, though, will become negative.
yeah. So it's negative. So negative 20 over 9. So it's negative.
Mm-hmm.
Good.
Meaning
Okay.
it's concave
So
down.
it's concave down. Let's go to new page here. So F double prime. We've got 1. Plug in negative 1. It's concave down. Let's plug in 2 now. Plug in 2. No, let's not plug in 2. We want to plug in something that we can take the cube root of. Plug in
9? No, you wouldn't be able
8.
to do that.
We can do 8.
Yes.
So plug in 8. We get 20 over 18. 9 times 2. Cube root of 8 is 2. So that's 18 minus 20 over 8. Let's see here. I'm going to mess this up.
The cube root of 8 is
4.
2, so 4.
36. Okay, which is positive. If I multiply by 2 over 2, that's 40 minus 20, which is positive. So that's positive, and I plugged in 8. All right, so it is an inflection point. It went from concave down to concave up. I think we can graph now.
Mm-hmm.
We can graph. So our points are, it goes through 0, 0, and it went through, what was it, 128?
128
over I think it was here, 128 over 5.
125 over
125 over 8. 125 over 8. There was, which is around 15.5. There was a minimum we saw at 8.
And a point of inflection at 1.
Point of inflection at 1. It's concave down, and it has a maximum at 0. Well, that was supposed to go through 0, 0. And then there's a point of inflection.
Minimum
Minimum at 8. And then it's concave up forever and ever and ever. And there's our graph. It's not an easy problem, but I don't think the algebra was too difficult. There's just a lot of it.
Yeah, I agree.
All right. Good job, Themis.
Thank you very much.